Hey guys, back in action over here. Whew, rough couple of days. Look, this is a lesson for the 8th, last Wednesday. So last we left off, we were doing series circuits. Seems like everybody's got that pretty good. So we're going to extend it a little bit, and we're going to introduce test points, test point voltages, ground, and potential and polarity. Go ahead and pause and write that if you want the agenda. So test points can be simply defined as points of interest inside the circuit itself. A lot of times in procedure, especially troubleshooting procedure, they'll have step by step. And what they'll do is they'll say, check the voltage at test point 1, check the voltage at test point 2. So these are just points within the circuit that we're interested in, our documentation determines we're interested in. Okay? So one thing you need to know about test points is how to measure test point voltages. So when we have the meter has two leads on it, okay? Now the test point, since that's the point that I want to measure, is where the red lead goes. But the thing is where does this black lead go? Well, the black lead is the test point is always referenced from ground. Now ground is defined, hold on. So the big thing to know about test point voltages is the red lead goes on the test point and the black lead goes to ground. Okay, so y'all do know to pause it and then write down what I've got. Okay, so here's the deal about ground. First of all, ground wasn't even introduced until 1971. I know it seems like a long time ago, but y'all probably been in some houses and seen wiring that still do not fall under that code. You'll see those little receptacles with the two slots in them. And then that's it. Well, when ground was introduced, that's when that came in. Now, this ground is actually connected to a wire that goes out by your meter pan. And if you go look at your meter pan, you'll see a bare copper wire coming down and attaching to a little metal post. Well, that metal post is down in the ground, probably about 6 feet. And so that connection puts ground potential at this point on the receptacles. Now, what good is that? Well, let me tell you something. I told you I'd never tell you a story while we were in class and all that, but this one pertains, so I want to tell you this one. When I was a kid, all of us cousins would gather over at my grandmother's house, play, get hot and sweaty, barefooted, sweat dripping, and then it'd be time to go inside and get something to drink. And we'd all sit around and argue about, oh, you go in and get Kool-Aid. No, I'm not going to get the Kool-Aid. You go get the Kool-Aid. No, I'm not going to get, I got it last time. And it went round and round because my grandmother's refrigerator, on a bad day, you could walk up and grab the handle on the refrigerator and just get shocked. I'm telling you that we didn't like it. My grandmother used to keep a oven mitt by the refrigerator so she could open the door. And as I got to realize, of course, later on in life, what had happened was, is the power cord, because of the vibration of the compressor and the motor, the power cord was rubbing up against the metal frame. And it eventually wore down until it had bare wire up against the frame of that refrigerator. So that put 120 volts on the metal outside of that refrigerator. So anytime you walked up to it, it was just like taking a butter knife and sticking it into a receptacle. Lord have mercy, it would light you up. So ground was introduced for consumer safety. Now what that does is everything that a consumer can touch that's conductive is going to be connected to this point. Now the reason that's important is because if this point is ground, what you're standing on, and you grab something that is at ground potential, there's zero difference in potential, therefore you're not going to get shocked. And if there is current on that neutral, it'll actually throw a breaker. So ground was introduced in 71 simply for consumer safety. All right, there's a couple of schematic symbols. So our earth ground, and that's what I was just talking about. And then we have chassis ground. Now chassis ground, primarily you're going to find chassis ground like in an automobile. You know, the negative side of that battery connects either to the engine block or the frame of the car, which is attached to the engine block. So everything on that frame, engine, is connected to the negative side of that battery. Well, the red side of the battery connects to a fuse box where all your different circuits are distributed. Tail lights, headlights, every part in the car that's fused up. And so if you think about it, the manufacturer will run a wire all the way back there to that back tail light, but do you think they're going to spend the money to run that wire out all the way back to the battery? They're not going to do that. They're going to take the negative side of that light and they're simply going to connect it to the frame because the frame is a conductor and it's connected to the negative side of the battery. All right, and so that completes the circuit. So this type of grounding, which is not in the earth, it's insulated by the tires on your car, is called a chassis ground. It is a common point in which to measure voltages. Okay, so let's get that down. Earth ground. All right, so and this is what I was talking about earlier, that the red lead on a test point goes to the test point, but the black lead goes to the common reference point for those measurements, which is ground. Okay, so that's the big deal about ground. It's such a misunderstood concept as far as electrical circuits, because everybody says, oh, it's shorted ground, it's shorted, it's straight to ground. And that isn't always necessarily true. We'll talk about shorts and opens coming up. But ground, common reference point for voltage measurements, test point voltages in particular. Okay, now there's something you have to remember when measuring voltage at a point in reference to ground. So here. So if I have a circuit, two series resistors, I want to pay attention to this source. Because the source has a long line and a short line for a reason. Y'all remember what that reason was? Yeah, the long line represents the positive side of the source and the short line represents the negative side of the source. Now, if my most negative point is connected to ground, and I have a test point here and a test point here, what you need to be aware of is, since I'm measuring from here, and voltage is a difference between 2 points. If I'm measuring here, I'm going to measure the voltage that's across test point 1. But you'll notice test point 1 is on the positive side of that source in reference to ground. Ground's the most negative. So I'm going to measure a positive voltage. I'm going to measure a positive voltage at test point 1, and from ground to test point 2, I'm also going to measure a positive voltage. Now, if test point 1 was here and ground was over here, well, test point 2 will still measure a positive voltage because it's on the positive side of ground. However, test point 1 being on the negative side of ground, is going to measure a negative voltage. Okay, so what's the difference between positive voltage and negative voltage? Well, I'll tell you this. They'll both shock you the same amount. It doesn't matter. Look here. In every voltage measurement, there are two indications. There's an indication of potential, and that's the number that comes up on the screen, and then polarity. Polarity is the negative and positiveness of that voltage, as in reference to the measurement from ground. So, potential, being the number, actually represents or will indicate the amount of flow. The amount of voltage, the potential, will determine, along with resistance, the amount of current flow. So potential indicates the amount of current, and because we learned that negative electrons are repelled from negative and attracted to positive, that my current flow direction is always negative to positive. So the direction of current is determined by the polarity of that measurement. So potential indicates the amount of flow, and polarity indicates the direction of flow, whether it's flowing toward the meter or away from the meter, based on the point that ground is. Okay, so look, I know there was a number 6 problem on that series worksheet, and some of you got it pretty good. Some of you are having a little bit of trouble. So let me show you one. Okay, so first thing I'm going to tell you, to figure these test point voltages out, you have to analyze the series circuit completely, because I need to know the individual voltage drops of the resistors, because like we discussed last week, that voltage in series adds back up. So I got to know how much voltage I'm supposed to have across each one of them. So what I'm going to be looking for is the voltage across test point 1, voltage at test point 2, and the voltage at test point 3. But before I can do that, I have to solve for the voltages across R1, R2, and R3, which means I'm going to have to take and add up all my resistances to get my total resistance. So when I add this up, yeah, I can see I got a 1.2 kilo ohm resistor. So that 1.2 kilo ohms that 1.2 kilo ohms divided into the 12 volts. So I'm going to take the 12 volts divided by 1.2 kilo ohms, and that gives me 10 milliamps. So my total current in this circuit is 10 milliamps. Okay, so 10 milliamps, that means that's the current through R1, that's the current through R2, and the current through R3, because there's only one path this current is going to flow in, and current in series with only one path will be the same everywhere, same amount of current flow. So what I need to do at this point is find the voltages across each one of these resistors. So I got 10 milliamps through each one of them. I got to find the voltage across resistor 1, the voltage across resistor 2, and the voltage across resistor 3. Okay, so if I do the math, I'm looking at it, 10, which is a number with 1 in it, times a number with 6 in it, it's going to have an answer that has 6 in it. So actually 600 ohms times 10 milliamps is going to give me 6 volts. Take that 10 milliamps times 200 ohms, and I get 2 volts. And take and multiply it times 400 ohms, and I get 4 volts. And as we discussed last week, that the sum of all these individual voltage drops adds up to equal the total applied voltage. And if I go to check it, 6 plus 2 is 8, plus 4 is 12 volts. So that accounts for all my voltage. So now, I'm ready to figure out how much voltage I have at my test points. And this is pretty easy, folks. Remember, all the test points that are on the negative side of ground will measure negative. So this test point 1, it's going to measure a negative voltage. Well, how much voltage is it going to measure? Well, if I stick my black lead on ground and stick my red lead on test point 1, what component is between my two fingers? Because that's what I'm measuring across. And so the voltage for R1 was 6 volts. So measuring from ground to test point 1, I'm going to measure a negative 6 volts. So it was just the voltage across R1. Now, if I want the voltage for test point 2, I'm going to do the same thing. But I'm also noticing now that test point 2 is on the positive side of that source. So I know test point 2 and test point 3 will both measure positive. And just like numbers in general, if you don't put a sign down, it's typically going to be considered a positive value. We indicate negative values with a minus sign, but we don't have to put the plus sign for the positive voltage. We can just write it down as a voltage. So test point 2, I'm going to do the same thing. I'm going to put my black lead on ground. I'm going to measure test point 2. Which component am I measuring across? That's R2. So I will measure only the voltage for R2. And we had determined that was 2 volts. Now, that was just one resistor. What do we do when we have 2 resistors between ground? Well, what did we decide? We decided that voltages across these resistors will add up. Voltage across these resistors will add up to be equal to that potential. So I know it's on the positive side of the source, so it's going to measure positive. And if I measure, put my test point, my red lead on test point 3, I'm measuring across both R2 and R3. So I'm going to measure the combined voltages of R2 and R3. Okay, so the combined voltages of R2 and R3, when added up, gives me 6 volts. That's test points, folks. Just remember, test points are always referenced from ground. Be the meter. Stick the black lead on ground and stick your red lead on the test point and see what components am I measuring across. And then once we've determined how much voltage each one of those have, we can just come in here and fill in the blanks. We might have to add a couple of them up to figure it out, but it's relatively simply an extension to the series circuit. All right, so I am going to put a couple of these on the board. Go ahead and pause it because I'm going to put them on the board and erase, put it on the board and erase. This will be y'all's assignment to get these circuits done here at the end of the video. Take pictures of it and go ahead and send it to me for your attendance. All right. So you are going to have to go through the entire analysis portion of it, and then once you get your voltages, you can determine the voltage test points in the circuit. All right. Okay, get down and copy it down, pause it, copy it. Okay, copy that one. I sure miss my classroom, folks. I know y'all do too. We're gonna get back there. It's gonna be over soon, so. Okay, there's your third one. So I'm thinking we're going to need to have a quiz next week, get this series circuit. The quiz is going to simply consist of one series analysis problem with test points. So study all that up. Make sure you remember the common points within the series circuit. Current's the same, you add up resistors, and the voltage divides and adds back up to the total voltage. Okay, so there's number 3. Get those 4 done. You didn't already do number 6 in the worksheet. Go back and do number 6. And then these 3 that I put up here, take a picture of it, email it to me so we can get your attendance. Again, folks, I'm sorry about the delay, but haven't been feeling good. And no, it's not corona related. It's all stomach. But anyway, y'all need to know that. All right. I'll wait for your questions if you got any. All right, guys, take it easy. Hang in there. We're going to be back. You know, the school is trying really hard to help you guys out any way we can. There's a certain amount of flexibility, but staying in touch and communicating is the most important thing. All right. So until next time, get this done. And we'll see you on the flip side. Make sure you have it turned in by next Tuesday so I can award the attendance for this past Thursday or Wednesday. All right, guys. See you later.